Guys, in this video we are going to start a new chapter which is called as chemical kinetics. So before digging with this chapter, there are certain reactions we have to study in order to understand that what is the main reason we are studying this chemical kinetics. Let us take an organic reaction, that is your tertiary butyl bromide. CH3, 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 Br. So when it is treated with alcoholic KOH, of course the reaction is what is happening. Your nucleophilic substitution reaction is taking place where your bromine part will be substituted with respect to that of your hydroxide, of course. But when I am taking this simple methyl bromide, that is your H, H and a H, and treatment with that of your KOH, of course what is the product is, whatever the OH is there, that will be coming and attacking your carbon from the opposite side with respect to your Br, and you'll be getting that of your methanol. Yes, but the main reason why we have chosen this reaction is, so when you're considering the first reaction, when I say whatever the product it has been formed, it says that to the experimental analysis, it only depends upon the concentration of your methyl bromide. That is, whatever may be the concentration of your KOH, it doesn't affect this reaction. That is the first point. Whereas in the second reaction, it says that whatever the product has been formed as a methanol, it depends upon both the reactants. Now the question arises, why is it so? So this why can be easily understood under the topic called as your chemical kinetics. To be more simple, of course this reaction was quite clumsy and also we are not able to, if you see that we are not able to understand. Let us go with some simpler examples. So for example, when we are doing the first PUC labs, we have shown that certain salts, yes, they were answering you, that is they were giving their present with respect to the dilute acids. True? The dilute H2SO4. But the same salts, the remaining other salts were giving you their appearance with respect to the concentrated acids. Yes, why was it so? So in order to answer such questions, our chemical kinetics plays a vital role. Then what does this chemical kinetics means? So it's a branch of chemistry, yes, which deals with the study of the reaction rates. That means how fast the reaction is taking place. Okay, so we study the reaction rates and their mechanism. Yeah, how this reaction is taking place and how fast this reaction is taking place. So that is called as what? Your chemical kinetics. So under this chemical kinetics, the most important term we are going to see, which is called as a rate of a chemical reaction. Rate of a chemical reaction. In simple words, if I had to say, means it is nothing, just it is called as velocity. Velocity of a chemical reaction. But in chemistry, instead of using the word or the term as velocity, we are using the word as rate. Very much important. Because whatever the chemical kinetics we are going to study, it mainly depends upon this factor of rate. That is, how fast the reaction is taking place. So how can we define this rate of a chemical reaction? Of course, when I am saying a chemical reaction, what does it mean? That is, you are having a reactant, you are having a product. So we are going to define this chemical rate of a chemical reaction with respect to both the terms, that is with respect to the reactant and with respect to the product. So how can we do it? Of course, I said rate is the velocity. We know that a reaction proceeds from your reactant to the product, alva. So we can define a rate of a chemical reaction as what? The rate of decrease in the concentration. Please mark my words. Rate of decrease in concentration of reactant, of any one reactant, if there are many reactants, rate of decrease in the concentration of the reactant per unit time. Per unit time. So that is the definition of a rate of a chemical reaction with respect to the reactants. Can you please help me to define the products part? Of course, it would be the rate of, yes, very good, increase in the concentration, rate of increase in the concentration of any one of the product per unit time. Per unit time is said to be as a rate of a chemical reaction with respect to the product. So this is called as rate of a chemical reaction. That is, we are going to see how fast your reactant is going to decrease per unit time when a reaction has been proceeded. Or in other terms, we can also say that how fast your product is going to form per unit time. That is called as rate of a chemical reaction. ಎಷ್ಟು ವೇಗವಾಗಿ ನಿಮ್ಮದ ಒಂದು chemical reaction ಆಗ್ತಾ ಉಂಟು. That is called as what? As a rate of a chemical reaction. Basically, this rate of a chemical reaction has two different types. So first one is called as average rate of a reaction. Average rate of a reaction. And the second one as the instantaneous rate of a reaction. Instantaneous rate of a reaction. So first we will understand what do you mean by this average rate of a reaction. Let us consider a hypothetical reaction, that is reactant giving you the product. That is 1 mole of the reactant is giving you that of your 1 mole of the product. Yes. So at time t1, let us consider at time t1, let the concentration of your reactant and that of your product be as R1 and that of your P1. Okay. So at time t2, after certain interval of the time, let the concentration of your reactant and product be as what? R2 and that of the P2. Yes. So now we have to see that what is this square bracket indicates in chemical kinetics. Remember guys, whenever in physical chemistry we are using this square brackets, it means it expresses the molar concentration. So your square brackets, whatever we are going to see, that represents what? Your molar concentration. That is certain concentration we have used with respect to your reactant, certain concentration of something we have taken, that is your product. So within the square bracket, whatever is there, that represents your molar concentration of your respective things. Now coming back to that of your average rate of a reaction, let me take your delta T as what? T2 minus T1. Of course, the delta R as that of your concentration of your R2 minus concentration of your R1. Similarly, that of your delta of P as the concentration of your P2 minus concentration of your P1. Now coming to the definition of your rate of a chemical reaction. So first of all, let us go with rate of decrease in the concentration of the reactant per unit time. So how can I write it? Of course, we know that whatever the decrease will be there, that is your R2 minus R1. Yes. So I can write over here as R2 minus R1 divided by T2 minus T1, or simply I can write it as delta of R by delta T. But now I have to indicate that of course it is rate of decrease. So when I merely see this equation, I cannot judge it whether it is increasing or decreasing. So as a sign convention, the rate of decrease with respect to the concentration of the reactant will be indicated as negative. Able to understand? So this negative sign is just an sign convention which is indicating that the reactants on proceeding the reaction is decreasing, because we know that velocity can never be negative. That should be there in your mind. So why does we have used this negative sign, which mainly indicates that with the progress of the time the concentration of your reactant is going on decreasing. So as that sign convention we have used over here as a negative sign. So this was with respect to the reactant. Now what we can say with the rate of the appearance of the products or the rate of the formation of the products, of course it would be as P2 minus P1 divided by T2 minus T1. So that will be equals to as what? Delta of P by delta T. So what is the sign here? It would be coming, of course, positive. Why is it so? Because with the progress of the time the product's concentration is going on increasing, and that is indicated with respect to your positive sign. So this is very much important. So now as a sort of definition for particularly for this average rate of a reaction, what we can say, so basically average rate of a reaction depends upon the change in the concentration of the reactants or change in the concentration of the products and the time taken for that change to occur. So it is giving you the information about at certain interval of time, for example from 20 to 40 minutes. In this interval of time, what will be the decrease in the concentration of the reactant and what will be the increase in the concentration of the product. So this ideology will be given by that of your average rate of a reaction. Then if I plot a graph in order to understand this, how can I plot it? Of course in this way. So in y-axis, of course time is in my hand, so I'm going to take it as in the x-axis, and this will be in y-axis the molar concentration of your reactants. Molar concentration of reactants. So when I plot a graph for the reactants for that of your in the average rate of a reaction, what happens? Initially at 0 nearly it would be very high. Yes, as the time is proceeding it decreases and goes on decreases in this way. Yes. So in order to this graph, if I want to calculate my change in the concentration of the reactant with respect to time, how will I do it? Let us say, as I chosen over here as a time interval, here I will choose the time interval as T1 and that of your T2. Okay. So let I take this one as my T1 so that it will be better my understanding is a T1, and let this be as my T2. So correspondingly when I am expanding those lines, let I may get for T1 the molar concentration of the reactant be X1. Of course what is happening at T2, what has happened as the time has proceeded, it has been decreased, alva. So X1 is here greater than that of your X2. So how can I find my average rate of a reaction? Of course it will be X2 minus X1 divided by T2 minus T1. So since it has been decreasing, the reactant concentration is going on decreasing with the passage of time, what I should use? Of course a negative sign. So which is a sign convention showing you that with respect to the time, the concentration goes on increases. Or in simple words, it's also a mathematical issue. Because when you are taking as a x2 minus x1, if this negative sign is not there, what you are going to get? A negative part. Because here x2 is smaller than that of your x1. Since x1 will be getting a negative, and we know what rate is nothing but the velocity. Velocity can never be negative. So when we are doing the problems, you will be getting a negative value for a velocity, which is an error. So that is the reason by this negative sign, which also indicates the with respect to the time, the concentration of the reactant goes on decreases. So when you take it, of course, the negative into negative will be giving you the positive value for your velocity. So this negative sign is very much important, which is indicating that with the passage of the time, the concentration of the reactant is going on decreasing. Now coming with respect to the products. So what you can see, of course, here will be what? Molar concentration of product, yes, versus your time. Initially the concentration of the product will be 0. So with the passage of the time, it is going to increase and increase. Yes, and becomes constant. So here if I take the two time intervals, because it is an average rate of a reaction, take it over here as T1, yes, and over here as that of your T2. So T1 ka corresponding I am going to get as my x1, and T2 ka corresponding I am going to get my x2. So average rate of a reaction with respect to the product will be what? Of course, here is what has happened. Your x1 is smaller than that of your x2. So when I take it as x2 minus x1 divided by T2 minus T1, of course this will be a positive quantity, which also indicates that the concentration of the product is going on increasing with respect to the time. So this was called as that of your average rate of a reaction. But guys, do remember that whenever we are reading a chemical reaction, of course it is very much important to know that what will be the reaction rate at that particular time. That is the main disadvantage of this average rate of a reaction. If we are noticing the average rate of a reaction, what it is giving you? It is giving you the information with respect to the time interval. But in chemistry, we mainly require, of course, what will be the rate of the reaction if I chose, for example, 20 to 40 minutes, they are giving you the rate. But if for 25th minute, particularly if I want, what will be the rate of the reaction? That cannot be answered by your average rate of a reaction. So in order to overcome this problem, a new rate of a reaction was proposed, which is called as instantaneous rate of a reaction. By the name itself, you are going to get instantaneous means what? At that particular time, whatever the reaction rate will be, what we are going to measure, that will be called as an instantaneous rate of a reaction, which will be seen in our next video.